So, the Hale Design Tech Torch Height Controller gets a mega upgrade, and I talk about more of the features that it has coming right up. Check it out, the Torch Height controller got this mega 2560 upgrade from the Arduino Uno R3 that was in there before. I don't have to change my bolts out. They are in the same spots because the Arduino ecosystem allows you to swap out boards with the same footprint, which is nice. And I also intentionally made the box a little bit wider just to accommodate a mega if I ever wanted to put one in here. I ended up seeing that the Arduino Uno was slightly underpowered for the calculations I wanted to have it run. So I upgraded to a mega. It's about 3 times faster and awesome. You'll need new firmware. Arduino firmware is not compatible with the EEPROM of the megas. I had to rewrite some of the firmware to get that to work. Also did some improvements to it. It's a little bit more responsive and it listens better to the inputs from the next-gen screen. So let's go over that in a minute and take a look at the settings and what this thing can do. I was having some dust problems with plasma cutting dust coming in and getting on all the components. Looked like it was high iron content, so probably highly electrically conductive. Not great for circuit boards. So I ended up putting some spacers behind these fans and sneaking in a bit of this carbon filter. You can get this off Amazon pretty cheap. Just type in carbon filter. And now I've ran into a few cuts and everything seems to be a lot cleaner in here. I don't think it's a perfect solution, but it's a step in the right direction. So in my other video, my original video, I was a little embarrassed about my connections I made here. So I finally just did them proper. DuPont plugs with male pins on them. You can get a kit to create these pretty cheap on Amazon. Just look for the ones that have the have a strip of the down pins, and then they go right into the Arduino. Pretty easy. And that's a much better way of doing the connections. Also, I'm not sure how you're doing your setup if you're making this, but I ended up moving the capacitor to this Keystone Ethernet adapter, and now it's over there. One, it's farther out of the way, and if it ends up, it's an electrolytic capacitor, so it technically could get overcharged and blow up. But it'll blow up right where that cut strip is on the back of it. So just right now it's pointing it right into the sidewall. It's pretty controlled if it does go. And I know exactly where to replace it if that happens. So this is probably a way better solution than having it right down here on the board itself. Yeah. So those are the main hardware updates I've made. And there's a Arduino Mega here now. Oh yep, I forgot to tell you that the firmware for the Mega is up on my GitHub. So if you want to download that, you can't use the same firmware you would use for the Uno. The EEPROMs are different between the two boards. So it uses a lot of memory storage. Alright, here's the Arduino IDE and the new Mega 2560 sketch. Oh, it opens another one. Alright, so first things first, we need line numbers. Okay. So, not much has changed here until we get to hardware check. This is new, so I want to make sure that this sketch is running on the Mega. So it won't compile unless it's running a Mega. If you take this out, it would compile. Just don't do that. I've removed my EEPROM library, and now I'm just using the standard one from Arduino. And I've added another serial connection, because that's the other main reason why I wanted to upgrade the Torch Height controller, because it would only use the one serial connection, and that means anytime the Arduino is running and connected to the next-gen screen, it would use that serial connection. You couldn't connect it to a computer, so you have to disconnect the display in order to flash or change the firmware on the Arduino, which is annoying. But since we got a Mega, we got multiple serial connections. So we just use, instead of serial 0, we just use serial 1 connection. Next, the basic inputs are the same. I'll come back and cover these in just a second. And we do some setups, read stuff from the EEPROM. We set some initial values for the first boot up. And then our loop function has changed a little bit. So while I'm on certain pages, I'm really focused on reading plasma voltage. But if I'm not on those pages, then I'm really focused on listening to the next-gen display and just doing all the other stuff. So this really helps speed up the settings pages, because sometimes the Arduino would ignore settings inputs because it was busy trying to read an analog input voltage. So this helps a lot, and then it's able to focus and double down on doing what it's supposed to be doing when you're on a different page that's not one of the settings pages. So don't run the torch height controller if you're not on one of the main pages, or let me just say it this way: don't run your plasma cutter when you're on a settings page, because that'd be bad, because it basically makes it so setting pages are turned off for reading plasma voltages. But the rest of it's pretty much the same. Couldn't really figure out any better way to optimize this. It seems to be pretty good. And I'm sure there's always a way to optimize it, and future versions will have those, obviously. But the first thing I wanted to show you guys is something I didn't show very well in the first initial video about this torch height controller. At least I think, anyway. Which is all of my settings. So I've got a few settings here, and let me just kind of talk through them real quick and what they do. So inputs, the plasma voltage input. Target input is set by that slider on each of the pages for the different materials. So in retrospect, the whole job of the torch height controller is to get this value to equal that one. And it does that by lifting up, moving the torch head up and down. So there's a gap. The gap is there for making sure that if it's 1 or 2 off, it doesn't try to chase that. If it's close enough, if it's within your gap range, plus or minus, then it's going to be okay with the input staying where it's at. That way the torch head doesn't just go up and down constantly. So if it's within your gap, then it won't move anymore. Then I've got a scale function here. That's for the settings pages, so it's 0.1, 1, or 10. A threshold is important for plasma cutters that have a lot of noise coming through their line. So the input's got a lot of noise in it, so maybe 10, 15 volts of noise just floating around in here. So the threshold just says if you're over that threshold, then start doing the computes and stuff. If not, just consider it background noise. So keep bumping your threshold up, and you can set that in the Arduino, or you can set that on the next-gen display. Just bump up your threshold voltage, or lower it if it's not working. Then this is just a internal measure the gap. Some internal things. Okay, here's another one you get to set in the settings, which is the arc stabilization delay. So when a plasma cutter first kicks on, it really fires through the voltage, so those voltage shoots way high until it stabilizes. which takes roughly a quarter to a half a second. The set point is... Oh, yeah. So the set point is what gets input from the slider on the page, which is what I told you this was. And then this is the calculated value after it hits gap and threshold. Whoops. Then the calibrated offset is for calibrating your input voltage. So if it's always 20 volts low, you can set your calibrated offset, and you can actually do that on the last page of the display. You can set that there, or you can just set it here with a value. Then the movement settings. These are pretty important to get right. I've put in stuff that works for me, but this is not going to work for every actuator or every plasma cutter. So you'll be playing around with these voltages a lot, and you can update. You can update both of these in on the TorchAct controller. So this is the aggressive PID settings, and this is the regular normal PID settings. So this is what it uses if it's way out, and this is what it uses if it's close to your input voltage, so the target. So if these two are close, it'll use this. If it's way out, then it'll go ahead and use the aggressive settings to get back into to range quickly. And so these are PID, which stands for proportional, integral, and derivative. So the main one you want to be playing with is this one, and kind of leave these at a low value. Look up PID settings. This is not there's way too much information to go into that, but play around with these settings first before you start messing with these. That's my advice. But you need to tune your TorchAct controller to your machine and your plasma cutter. So you just cut up some scrap metal while changing these settings. So run a cut. If it's bad, bump it up, bump it down. Run another cut. So that's what I did. So I sliced up some good metal to get these settings for me. Then the default refresh rate for the algorithm, the PID algorithm, I'll just leave that at 8. Leave that at 16 because it gives it the most room to maneuver its calculations. And then this bool is for if it's for chasing if it's high or low, it changes it from green to red on the display. Which it's nice to have, but not necessary. Then it goes through setups and everything. One thing I can say about setups of the EEPROM is if you got a knockoff Arduino, then it might have a knockoff EEPROM, which means it'll have less values. So my values for the EEPROM addresses go all the way up to 800. And sometimes the knockoff EEPROMs stop at 512 or 5 whatever. So if that happens, you'll need to come through and come back in here and change these to all be farther enough to set apart. So you need them to have at least 10 bits apart. But to not exceed the maximum of your EEPROM on whatever board you're using. So I had a few people run into that, so that's why I brought it up. But if you're using the Arduino if you're using the original Arduino, not a copycat, then these values will work for you just fine. And this is the default set voltage. You can't change this anywhere except for here in the firmware. So maybe I should move that up to here. I don't know. It's there. That's where it is. Then these are the initializes the page pages as 0, and then it'll read from the EEPROM to get the actual pages. So if you're seeing your your pages are always 0, or your settings, like these settings are always 0, then you're probably running into this problem here with the EEPROM addresses being cut off. Other than that, steps per millimeter, you can set that in the firmware. On the display, but you can also set it here in the firmware. Then it does some calculations per millimeters. To steps, then goes through and sets all your EEPROMs, and then fires up the connections and boots the whole thing up. And then this is the last thing down here right before it gets into the loop. This is the last thing. Well, second to last thing. I want to talk about this real quick. These are the settings that seem to work for me for the max speed and max acceleration. Because I find that the driver board that I'm using is a little weird. Either it's skipping steps or something. I'm not sure. But I have to crank my step speeds way the heck up for it to move as fast as I want it to move. So these will definitely be different for you, and you'll have to tune them. So you want your actuator to move as fast as it can without missing steps. And since it's only chucking around the torch height, the torch itself, you should be able to move the torch pretty quick. And then finally this is important for the driver board. The makes it only applies to the makes driver board. Because it's not a constant signal that keeps the makes driver board enabled. It's a on-off signal. So you send a high, then you wait, and then you send a low, and then the driver board's enabled for steps. A lot of people run into just sending it a high, and just if its enable pin is high, then the board should be working, right? No, not for make driver boards, or the driver board I'm using. You have to send it a high and then a low for it to turn on and be activated. That took me a little while to figure out. But besides the little quirks that it has, it's an actually really nice driver. It's quiet. It produces a good bit of heat, but it's also got a lot of stealth chop technology that the Trinamics driver has in it. But anyway, that's more detail about the Arduino code running on the Hail Design Tech torch height controller. And I hope hope this helps a little bit if you're trying to set this thing up. And let the discussion section of the Open Builds page be where you ask questions. Try not to ask questions on YouTube or ask in both places because it's kind of hard to monitor this project while I have other projects going on and stuff. So I just ask that you keep things on Open's builds if you have a question. And you can get this new Hail Design Torch Height Controller Mega 2560 sketch up on my GitHub now. It's available. It's up there and it's available. So you can go download it and grab it if you want to upgrade to a Mega, if you have one sitting around. Remember, Megas also have copycats, so you might run into this issue or some other thing that a copycat has. So I always suggest buying the original Arduinos. Alright, that's the upgrades to the Hail Design Tech Torch Height controller, and I hope you guys found this video interesting. And I've noticed that the Arduino Mega really performs way better than the Arduino in the PID calculation settings. And also you'll find a nice bump up in responsiveness in the display on the next gen screen as well. Just because it has that second serial connection available. But yep. Thanks guys. If you liked my content, go ahead and hit subscribe If you're new to my channel, I built a giant 3D printer called the Autocrafter, and it's also the plasma cutter. So go ahead and check out that build series. It's popping up on the screen here. And down below is a video that YouTube thinks you might like. So have a good day.